You're listening to the Luminate series on the Forward Faster podcast, providing bite-sized insights for entrepreneurs in the optics, photonics, and imaging sector.
Trying to create an optical manufacturing startup is particularly ambitious. And the question there is, how do you even create the momentum to do something like that? Today, our guest is Jeremy Goeckeritz of Momentum Optics, and we're going to be talking to him about his methods for making optics that are faster and cheaper and maintain the same level of quality. My name is Damon Deal, and I'm the Technology Program Manager here at Luminate. And this is the Next Core Forward Faster podcast, in case I didn't do that already. And hi, Jeremy. Nice to see you today. How are you doing?
Thanks, Damon. I'm great. It's a pleasure to be here.
Okay. The first question I always ask people is, what is the problem that you're trying to solve and why is it important?
Yeah, the problem is really threefold. We're trying to address the issue of cost of small optical components. So a small optical element, the materials might only be a few dollars, but once you start to machine these with high precision and low surface roughness, they increase dramatically in cost. Mm-hmm. So to give you an example, I was working on a project where I needed a micro lens array, and we sent out a quote request. We got 3 back, and they came back from $5,000 to $25,000. At the low end, it was $5,000, and that was because it was a low cost Asian supplier, and then the other 2 manufacturers were in the United States. But that Asian supplier, the problem there was that the lead time was astronomical. It was about 10 to 12 weeks, which brings me to the second problem, and that is the time that it takes to manufacture optics. So we live in a world where you can get rapid prototyped metal parts and 3D printed parts, but getting high precision small optics quickly is not possible. So we're trying to address that issue. Mm-hmm. And then lastly, optics are challenging to do well. So manufacturing with high precision and low surface roughness, low figure error, doing all these things right, and doing it over and over repeatedly is a challenge.
Can you get a little bit into why it's so important to be able to have these kind of optical elements and hitting on these lower price points and accuracy and volume?
Yeah, so 2 things there. We're trying to make optics more accessible, particularly custom optics. So we want a wider customer base to be able to use optics. We've been doing this customer discovery process, and we keep hearing the same thing. We're designing around the catalog. So rather than designing for what's best for their project, mm-hmm. they're looking at the catalog and saying, here's what's available during the timeline we have. So that's a big issue. And then the second thing is, when you can make custom optics, you can make them specific for an application, so you get better results.
Yeah. When I'm trying to give people an understanding of why these freeform optics are so important, I pull out my phone, because the reason phones have been able to get this incredibly thin is because they're not using conventional surfaces anymore. But as you say, unless you're Apple, the volume of making those at any sort of expense is, well, not just Apple. I'm sorry, I'm an Apple product user. There are, in fact, other people who make products. But these high volume producers, yeah, it is, until you get into molded optics, it's incredibly expensive. And so you're able to do prototyping at that level as well, right? That's one of the neat things.
Yeah, that's exactly right. I don't know of any companies actually doing rapid prototyping of those small optics, the type of optics you were referring to, 5 millimeters or smaller. If you think about, optics that are done with, say, diamond turning or CNC machining, imagine trying to fix a very tiny piece of glass onto a stage and hold it there while machining it. Yeah. So when you get into these really tiny optics, these sub 3 millimeters or smaller, it's very challenging. You almost have to go to molding. And like you said, if you go to molding, that's great, but molds can cost $25,000, and you may need special tooling just to make the mold. So we're talking about a huge upfront cost. And unless you're, like you say, going to high volume, you can't just amortize that cost over 100 parts, or it's just not. It doesn't make economic sense.
Yeah. And it's really fun to handle 3 millimeter optics, by the way.
Yeah, you got to have tweezers.
You can go through a couple expensive ones by just dropping them on the floor and not noticing. Without getting into too much technical detail, because this is a very technical thing, can you talk a little bit about your approach for making these kinds of optics?
Yeah, absolutely. So we leverage technology from the semiconductor industry and we're combining that with a new material processing technique that uses lasers. So the idea is that we take these two worlds of semiconductor world and MEMS processing and combine that with optics to create this smart manufacturing tool. So the tool relies on the laser, but then also has a measurement system involved. So we can see the optic in real time and correct for aberrations.
That's really interesting. This idea that you are merging these two different fields. And so your background is coming from the semiconductor industry and you're translating that into the optics industry as opposed to coming from optics originally. Okay. Yeah, that's really interesting.
Yeah, I worked for a MEMS company for about 5 years. And then I did my PhD in optics. So it's really the confluence of those two things that, gave birth to this idea and this startup company.
Yeah. There are very few things that are just purely optics. There are optics in everything, but you find people who move into optics from all sorts of industries or are in an industry and they're in optics and they move into that. It's incredibly fluid because optics seems to be in everything. And that was really interesting about how you are leveraging that as a market advantage, where you're coming from originally. I'm curious, so as an entrepreneur, what are some surprises that came to you as you decided to start your own company? In particular, you're starting an optical manufacturing company, which is particularly ambitious.
Yeah, I mean, there's the challenges everyone faces, right? Just raising capital, hiring the right people, finding that product market fit. But I think with optics, there's its own unique challenges with the precision people are looking for, and people really want perfection. They give you a lens and they say, here's this aspheric lens equation. It's got 8 coefficients on it. So we're talking like nanometer precision. Like, okay, can you make this for me? Like, well, yeah, I can try. I don't know that anybody can possibly do like the atomic precision you're talking about, but it's I guess it stems from the fact that people use these simulation modeling programs, and the model spits out a particular lens, and they're like, okay, make this exactly. Like, well, that's not exactly possible. We're getting close. People are doing fantastic things in this area.
Yeah, we use that as a verb. We call it code 5ing something when somebody uses code 5 or some other design program and they don't really understand the complexity of the manufacturing.
Yeah.
And so is there anything else that you found surprising as an entrepreneur as you were just deciding you were going to launch into this career?
Yeah, I mean, I didn't expect it to be so hard to reach. I guess I'll call it escape velocity, where it's sort of self-perpetuating. It doesn't have to be sales. I mean, sales is the ultimate goal in being profitable. But even just having enough cash just to do the basic stuff, right? That's turned out to be a challenge that I didn't anticipate.
So what are some ways that you have addressed that? And is there any advice you could give to entrepreneurs as far as, I like that term, to get to escape velocity?
It doesn't have to be that you're profitable, but it just escape velocity, have enough momentum to keep going forward. At some point, you have enough knowledge and experience and staff and things. It's self-perpetuating. But yeah, I think we've had success with the Small Business Innovation Research grants, SBIRs. That's been a great program. So if you're doing deep tech and you're an entrepreneur, you should definitely take advantage of that. I think that's probably my best advice.
So that's really interesting what you're saying about the escape velocity. You have the word momentum in your name. Where did the word momentum come from? You mentioned momentum as we were talking. I was just curious what the origin was.
Well, one of our value propositions is fast turnaround, rapid prototype optics. And so I think that sort of plays into that idea that you don't lose momentum by waiting for optics as a customer, right? You keep that forward momentum, you receive your optics fast and seamlessly. And I think that all plays into the name that we chose.
What was your nudge toward becoming an entrepreneur, to starting your own company? That's a big jump from being a graduate student.
Yeah. Well, I worked for 2 startup companies after grad school.
Okay.
So I worked for one doing medical devices, small MEMS type of devices, and then actually in a foundry, a MEMS foundry, doing sensors. So both of those were startups. And I think I learned a lot about what not to do from those companies.
Yeah.
And I thought, I can do this. Maybe that's a little, I don't know if that's arrogant, but at the same time, it's always been a passion though. As a grad student, I worked for an entrepreneur center as a student associate. So I was teamed with an MBA student, and we worked on commercialization efforts for physicists technology. So I think that's really where I got the urge to start a company, and I've just been waiting for the right time.
Well, you are coming into this with a lot more background than most people that I can tell. If you have worked for two startups and worked in a center as well. You said that you saw some mistakes when you worked from some other companies without
Yeah, I don't want to go
naming names.
into.
What are some problems that you saw that you were able to avoid just because you'd seen them happen?
So I'd say both situations. It was the owner had no, there was no opposite force to the owner, right? So it's just sort of whatever he says goes, and you have to have really good feedback from people. So you have to be willing to listen to people and accept advice from wherever it comes. And if there's no one pushing back, things can just run out of control.
That is a point that people haven't made on here before. When I ask somebody, so what's the most important thing you need besides money? Everybody says their team, which is why I stopped asking the question, because it's always the same answer. But no one has ever said that part of the thing that you need in your team is someone who will give you some pushback on your ideas. And yeah, that's really, really great advice, because you can run into a lot of problems if you got a bunch of yes men around you who just they don't play devil's advocate.
Sometimes it's okay if you're like this brilliant person who knows exactly how to run a company, but if you're new to it and you're trying to implement ideas that are just crazy and no one's saying anything, you're gonna lose people. And that's a big challenge. You're trying to retain people in startups, and keep people motivated. They may be working long hours and they could go make money, working for a big tech company, but you want to keep people motivated and happy.
What did you want to be when you were a kid?
Very early on, I wanted to be a professional race car driver.
Okay.
But once I had a little more understanding of how the world worked, I wanted to go into medicine. And then ultimately, I figured I could help a lot more people if I were an engineer. So at some point, I decided engineering was the right choice for me. It's surprising that I didn't go directly to engineering, because I tinkered a lot as a kid. I played with motors, and I was the one that was always assembling friends and families' gifts and Christmas and birthdays and things like that. I put together their bikes and things like that for them. So it's kind of surprising I didn't choose that career path earlier.
You would not be the first person I know who went from race car driver to optics. I know a guy who's a Porsche mechanic, and he became an optical engineer. But his dad is still a Porsche racer. So one other thing that we do as sort of a game is fill in the blank. Entrepreneurs are blank.
Essential to our modern world.
There you go.
And exceptionally optimistic people.
Yeah.
You have to be very optimistic and confident. You always think, oh, this next one's going to work. I'll be making something in the lab, and it'll fail 1,000 times, right? It only has to work one time, but it'll fail 1,000 times. And every time I think, this is it. This is the one that's going to work.
You've been working in the startup community for a while. Like you said, you've worked for two startups before. You've got one now. Are there any trend that you have seen in becoming an entrepreneur?
Yeah, I think one of the biggest trends is that universities, this has been going on for a while, universities have been looking at commercialization a lot harder. At some point it was more about basic research, but I think over the last decade, or maybe even longer, there's been a trend towards more commercialization efforts. So I saw that a lot as a grad student. And it's always been going on at certain universities, MIT and Stanford. They've always had strong entrepreneur programs, but I think it's impacting, it's starting to take hold in all universities, where they're looking at, okay, this technology has real potential. Let's see if we can commercialize it. So I think that's starting to impact the startup world.
A company we had on here a couple of weeks ago, and Luca, they are spinning a technology out of Princeton.
Right.
And also along the lines of what you're talking about, a big part of their development has been through the SBIR program as well. So yeah, we've definitely seen a lot of universities working to try to bring more intellectual property out. And the last thing is to inspire our listeners in 10 words or less. Is there a message you'd like to leave our listeners with?
Take care of yourself, and if you can, take care of someone else. We could all use an extra hand these days. A little more patience and compassion, I think, is warranted.
Thank you, Jeremy. This has been incredibly interesting. And to our viewers, thank you for watching. Please like and subscribe to this channel. You can also catch us on Spotify, and see you next time.